find the area bound by the lines, find the area bound by the lines y equal to 4x plus 5, y equal to 5 minus x, and 4y equal to x plus 5. Now this area can be found by integration, but it will be very clumsy. The best thing is to find the point of intersection of these three lines and then simply use determinants. So let us do it that way. For CET it is very suitable. So let us first solve these two equations. That gives you 5x equal to 0. That gives you x equal to 0 and y equal to 5. So one point between this and this is 0, 5. Let us see the other point. Let us solve these two equations. That gives you y is equal to 2. And if you put y equal to 2, you will get x equal to 3. Now to solve the last equation, this one and this one. It's a very pretty 10th standard stuff. I don't think it should bother you much. That gives you x equal to minus 1 and y equal to 1. So what are our 3 points? 0, 5, 3, 2 and minus 1, 1. They form a triangle obviously. So let us use determinant to find the area. x1, x2, x3, y1, y2, y3. Even though the answer is negative, you have to consider the mod, and the answer is 15 by 2. So this is a pretty simple way of solving area bounded by 3 lines. Don't go for integration. It is going to be very clumsy, very troublesome. Now let us do some trigonometric areas. Let us consider sin x and cos x. Please keep one thing in mind. Whether a curve is sine or cos, if you divide this into 4 quadrants, please remember that you can actually do it. Each quadrant will have area 1 unit. So don't forget that each quadrant will have its area 1 unit and total area will be 4. So let us do some trigonometric areas. We want to find the area included between the curves y equal to sin x and y equal to cos x. And x-axis. So let's see the situation. This is the curve y equal to sin x. You know at x equal to pi by 4, both sin and cos are 1, same. So y equal to cos x will pass like this. But we are not bothered, we are bothered about y equal to sin x, y equal to cos x and x-axis, means we are interested in this area. So let us draw strip, divides it into two parts. One part is sin, another part is cos x. Common point is pi by 4. So it will be 0 to pi by 4. First you can see it will be sin x. And between pi by 4 to pi by 2, which is this region, it will be cos x. Now integration of sin x is minus cos x. Integration of cos x is sin x. Cos pi by 4 is minus 1 by root 2. Minus minus will become plus, cos 0 is 1, plus sin pi by 2 is 1, and sin pi by 4 is again minus 1 by root 2. So it is 2 minus 2 by root 2, which is 2 minus root 2. So this is the required area. Suppose they ask you the same problem but not x-axis. They ask you y-axis. Then you want this area. You are already aware that this 1/4 area is 1 unit. So the required area will be 1 minus what you obtained here, 2 minus root 2. So it will be 1 minus, and that will be root 2 minus. As simple as that. Okay. Now one thing is remaining, that is area between two circles. It is going to be lengthy, but we have to do it because there is one sum that is remaining here, one type. So we want to find the area between x square plus y square equal to 4 and x minus 2 square plus y square. The center of this circle will be 0 0, radius will be 2. Center of this circle will be 2 0, and we have to find the radius here. In order to find the radius, we'll have to actually get it in a standard form. Which is this. And if you use the same thing, g square plus f square minus c and all, you will still get that 2g equal to minus 4, that gives you g equal to minus 2. F and c are 0, so the radius will be 2 again. So both the circles will have same radius. It is signed at a point of intersection now. If you consider the two circles, you will have x square equal to x minus 2 bracket square. And that gives you x equal to x minus 2, or and that gives you x equal to 1. X equal to x minus 2 is not possible, so it gives you x equal to 1. The circles intersect and the point whose x coordinate is 1. Now let us draw these two circles. This is the first circle passing through origin. This is the point x equal to 2. The second circle passes through 2, 0 and its radius is 2. 4, something like this. This point will be x equal to 1, which is the common point of intersection. This circle is and this circle is and all I do is integrate. This is the first step and this is the second step. So what is the required area between 0 to 1? It is this circle, and in this case between 1 to 2 it will be this circle. I think you can indicate this because you have done it in the previous sum. Please integrate this and I will tell you the answer. The answer is 8 pi by 3 minus 2 root. Please check this because we have done it in the previous sum, so you can check it out. Let us do one last modulus function sum. Now, even though it is integrated, let us do it quickly. And we are used to this curve. When x is greater than 1, y is x minus 1 and y is 1 minus x. When x is less than 1, this so you already know. What about this? Y equal to minus of x minus 1 plus 1. That is y equal to minus x plus 2, and when x is less than 1, we simply have y equal to x. So we have these 4 graphs to draw. We draw these 4 graphs, we will get a quadrilateral and then we will find a area. For x greater than 1 we have y equal to x minus 1 and let me check. Minus x plus 2. So let let us draw these two graphs when x is greater than 1. Approximately x equal to 0, y is minus 1, and when y is 0, x is 1, but we want the graph to be x for x greater than 1, so we will consider only this. Let us consider this. When x is 0, y is 2, and when y is 0, x is 2. So this is the graph. But again we want it only for x greater than 1. Let us solve these two and first of all check it out. Gives you 2x equal to 3x equal to 3 by the 1.5. It lies exactly in between. And this is the graph. Now for x less than 1, we have one graph as y equal to 1 minus x. Now let us see y equal to 1 minus x. When x is 0, y is 1. When y is 0, x is 1. So this is the graph. Okay, now the next graph is y equal to x. So this is the next graph, y equal to x. It is to be used only when x is less than 1, so only this much. Next part is not required. So we get this quadrilateral. This point I know x is 1.5. If x is 1.5, y is also 1.5. So this point is 1.5, 1.5. This point is 1, 0. Let us consider this point. This is y equal to x and y equal to x minus 1. Sorry, y equal to x and y equal to 1 minus x. So x equal to 1 minus x gives you x equal to 0.5 and y equal to 0.5. So this point will be 0.5, 0.5. This particular point. And what about this point? This point is y equal to minus x plus 2 and y equal to x. That gives you x equal to 1 and y equal to 1. So we have got a quadrilateral with these points. Now let us see if this quadrilateral is a rectangle. I don't think so, because let's see, y equal to x minus 1 and y equal to minus x plus 2 have a slope whose product is minus 1, so this is 90 degree. Y equal to x minus 1 and y equal to 1 minus x is also 90 degree. Yes. Y equal to x, and so yes, it is a rectangle. So let us find the length and the breadth, and we should be able to get the required area by using length into breadth equal to area. So let us find this length. This length will be 1.5 minus 1, that is 0.5 ka square, plus 1.5 minus 1.5 ka square. That will be square root of 0.5. This also will be the same, 0.5 ka bracket square plus 0.5 ka bracket square. So length and breadth will both be 1 by root 2, and the answer will be 1 by 2. So this is the way you do modulus function areas. I think that should be enough. I have done enough illustrations for areas, and we can